Hey dudes, I'm back again, and this time I just wanna do some basic stuff with the fiber algorithm. So the truth is that I already did this back in, I think it was in July when I started digging around how fiber works. So there is another repo when I initially went over all the things. So I just copied some of the code from there, what I already did. And I just basically what I will do is as I move along, I wanna go through all the code before I get into like some parts of the video. I wanna read some of the source code in the React GitHub repo, also reread something, but eventually I just wanna refresh all the things I done, because a lot of things has been done in that repo, so I just wanna create more mature version of that. So in the last part I set up all the initial things. I changed a few bits. So for example, I added the DevTool source map, which will enable us to have the source code of the client side in the browser. So if something fails or we just don't know what's going on, we will be able to navigate to the source code instead of the uglified, minified version, whatever is using. Also, I did a README file, a Markdown. I haven't written anything there yet. And what else? Yeah, I think I deleted the button here, so now if I refresh it, it's just element tag is not defined. So if I refresh it, it's just from source and from client. It's basically an empty HTML tag, but apart from that I haven't done anything. So what I have here, I'm just gonna close this because there is no point of watching these. They are not gonna change anytime soon. So like, why fiber? So what is fiber? Basically fiber is a data structure, basically, which has a few I don't know, it probably has more things going on, but these are the things that we will need eventually. So also it must have another, which will be we'll need at when we start implementing the hooks. I suppose we have every tag type parent. Okay, so these are the things. This is the fiber. So this is representing the instance that you create. So there was a blog post back in the day, I think it was 2015, with the stack with React Stack. Dan Abramov wrote that what's the difference between elements, components, and instances, and the other algorithm, as far as I know, use the word instance, and that is pretty much what we have here in fiber. So we have elements in React. Oh well, that's definitely not what I wanted to do. So we have elements, we have instance, and we have component. Okay, so just some basic things. Like, we all know what elements are, so these are the React elements. React elements, initially we write it in JSX, like, and for example, if you have a mutation component, if you ever used React Holo, and you write it in JSX, and it does some things, right? So I don't know, maybe you wanna render a button. Does these things, like, okay, and it will have the mutation name. Okay, so this is JSX, which is gonna get compiled into a function called like react.createElement. It will have the type it will have the props, and it will have the children, and that is a React element. So a React element is nothing more than like this. This is an object. So it's gonna be mutation. It's gonna have some props. So in this case, props will be like, you probably need to pass the mutation down there as a tag, a GraphQL tag. Let's pretend that you import it from somewhere else, like mutation name. So props will be mutation equal mutation name, and then we will have children, which is gonna be like I don't know how it's converted, to be honest. We will see the implementation down here at what we are doing, but that's definitely not what React does. So I think that's probably the first thing that it differs. But yeah, I think it's just converts it to either an array. Yeah, it's, or maybe the rest of it is just I honestly don't know. I'd be lying if I know how children is gonna be yeah, how gonna be interpreted by create React element. But let's just assume that first is type, second is the props, and all the others are the children. So in this case we can just put it here like function mutation name, and the function body is return, and it's another JSX, right? So it's not that type. In this case it's a string. We will get to it why it's a string, with the props of what props does it have? None. So props is empty, and children is just simply book. Yeah, so probably I wanna break it up. Yeah, so that's probably a way it gets compiled, because if you watch it, it's a spread operator here, so it grabs everything and puts them into an array. So I think that's what happens. So it puts, so that's the children, and that's the buttons children. So that's basically a React element. Okay, so instance fiber is an internal representation of the thing. It has a lot of data in it, and they are needed for determining whether you need a re-render or not. So yeah, that's the core of the algorithm. And component, we all know what component is. Component is just basically like a class-based component. So you instantiate, you instantiate from like a normal JavaScript class, and then React will create an instance out of it. I mean, instance by it's just not like an instance / fiber, but a normal object out of it. Okay, and actually if you have a ref that is pointing into component, then these components have access to their underlying fiber. So you can actually see it. Maybe if some later video I will be back to a normal React project, we can actually see the fiber that React creates for every component. Okay, so that's the fiber. Let's get through it. So tag is I don't even know how to start it. Yeah, because it's pretty complicated and all of them are connected together. Okay, so let's start with the type. So type is directly derived from the element. So you have your JSX. So in case your JSX is a class-based component or a function-based component, like they are eventually have the type of the given class. So for example, this is mutation, or if you have a function-based component, whatever the function is called, that's gonna be the type. So in this case, what if we just copy that? And what I'm trying to do is I'm trying to map it, if I can. If not, then I'm just gonna leave it. So the type is mutation. The tag is whether it's a class-based component, function-based component, or a normal div element. So, or how should we call it? Host elements, host tag. Yeah. So if I have something like, as in this case, class mutation extends component, then the tag will be something which will be identified by a string, but the string will be used as an enum. So we can have const class tag, for example, but we can name something else later on. So we can have classes, we can have functional components. So class const mutation. No, then we can have functional components, but the main distinction is between like classes / functions and the native dominance. So native dominance always represented with strings, as you can see. So for example here, mutation is a reference to mutation, whereas the button will get interpreted as a string like button. So if we take, for example, this button, then tag will be like, I don't know what to call it at the moment. We will see what I call it in the previous repo. You can call it native element or host element, something like that. Type definitely going to be button as a string, and it's a crucial distinction. So it needs to be a button. Parent is definitely it's parent because it's a tree, so it's trying to represent the DOM structure. So we will have parents, we will have child, but not children. That's important, and we will have siblings. So the relationship will be one-on-one on every term. So if you imagine the layers from top to bottom, you will have parent, which will have a child, which will have a sibling, which might have a sibling, which might have a sibling. It might have a child, it might have a sibling, it might have a child, but never multiple children or multiple siblings. So for example, in a structure like structure like this. This is a parent, this is a child, which has a child, and which has a sibling. So the way to get from this one to this is not simply just call parent, or I might be wrong. I don't. Oh, okay. So I might be wrong on this one. I have no idea. I need to look into this. But anyways, the main thing is that to access from this as a parent to the other child, you need to go to the first child. So there are the relationships between these fibers are more strict than simply just having multiple children. Okay, so all right. Yeah, alternate. Alternate is basically we're building up. Okay, so the way things work, how it's differentiate between props and everything, and it determines whether you need to re-render some parts of the application, is that it creates the initial render and saves it in one tree, and when another event triggers something in the application, then it will start building up the tree, and it has like every fiber has a reference to its if it's an update. Obviously, if it's a newly created thing, then obviously you won't have an alternate fiber. But let's just assume that you're just doing some update. Then how it does it is it has a reference. It saves the reference to the alternate fiber, which is the state from the previous render, so you can have access to whatever happened previously, and that's how you basically just keeping track of what happened. State node is the fiber itself. So if you, and this is copied from an update process, so that's why you have alternate fiber state node, because if you do an update process, then you don't need to create a new fiber. You just need to get the previous fiber and update things accordingly. Props is like it's a direct mapping to what props you had, but obviously React elements are just a proxy of what's gonna happen. So as I discussed in the previous video, like elements are kind of a functional way of describing declaratively what to do, and fiber will interpret it and will do the necessary steps to make it happen and paint it on the browser. You have partial states. So partial state is basically if you call set state, then you have your state and you have the partial state is what gonna be updated. So from the partial state and the previous state, it's gonna merge the two of them together, and it will be the state of the upcoming render. Effect tag is describing what will happen. So it's, as I said, it's an update. That's why you have the alternate fiber. If it's a creation, I think it's called placement in React. So it can be placement, deletion, and update. So placement obviously happens on every fiber when you do the first render, because that's the first render, so everything needs to be created. But on subsequent renders, it happens when you, for example, conditionally need to render something and it wasn't in the DOM tree. So the effect tag will be placement. In this case, you don't have an alternate fiber, obviously, because that's the first iteration when the fiber is created. And the effect needs to behave differently on placement and on update. And the third one is deletion, when you remove you saying the algorithm to remove everything related to the fiber from the DOM structure. Memo state, update queue are like hooks related stuff, so I'm not gonna get into these things. And effects are basically like how would I say, it's like events when they are bubbling up from the bottom to the top. So once you've done your job and you calculated all the fibers, when you coming from the algorithm from the bottom to the top, you're trying to gather all the effects and put it into an array. So there you know what effects needs to be flushed out to the DOM. And so it might be a bit too much for starters, but I just want to make sure that there are like two phases here, right? So the whole point was of this fiber architecture, before we dive into anything, is to be able to pause rendering. But actually, as you think about it, there will be two phases, as you might suggest. So there is one phase which is called render, and I think the React guys call the other phase painting. And from the perspective of the algorithm and the perspective of as a developer, so you write your code, which will be just React elements, right? Nothing more, just React elements. Based on the React elements, the fiber algorithm finds out what needs to be done. So from your React elements, it creates your fiber tags, and all the fibers will be created. That's the phase of rendering, when it gathers the information about what needs to be done. There are certain lifecycle methods which are called in this phase. For example, should component update. But as the name suggests, the crucial part is to gather the effects, like effects, side effects. It's basically the same thing. So your fibers will have all the properties, all the calculated properties along the render phase, and whatever needs to be done in the DOM will be created as an effect. So it's not gonna do everything. Just think about it. This effect will contain information that, okay, so create, it's gonna be something like create div with style something, create button, so it's gonna be an array of effects. So it's gonna contain all the things that needs to be done in the DOM. So along the render phase, nothing will be committed to the DOM, so you can pause it. It's just a calculation. But and after it's done, there comes the painting phase, and the painting phase when all the effects are flushed out, and React will communicate with the DOM API. So that's the actual part where the side effects will take place. And because, if you think about it, you can't pause, I mean you can, but you can't pause the DOM paintings because it would lead to UI inconsistencies. So what if you, for example, paint half of the divs, then pause it for a certain amount of time, and there will be an inconsistency in the UI layer. So what happens, as my understanding is, that render phase can be paused, but once everything has been rendered and the effects array is full, I mean everything has been processed, comes the painting, and once the painting has begun, there's no way to stop it. It will run until it's finished. So that's how it works. Yeah, so if I need to do something, then you write your elements, React from these elements, create the underlying fiber data structure which holds every information that you need to have to make the diffing, and based on them it will have all the information of what needs to be done, which we can call effects, and then comes the painting. So that's pretty much what will happen later on. Okay, so I think I'm gonna leave these, get rid of that, get rid of this, and the other thing I wanna discuss in this video is the create element. So that's why we need Babel, and that's what's responsible for compiling the JSX to function calls. So what happens here is you have type, you have config, and you have the arguments here. So okay, so eventually you will just return the type and the props, because if you just remember, when you console log this.props, you will have children as a props. When you render your children, it's just this.props as children, and you can render your children. So it's not a third argument, whereas the create element accepts the children as a third argument. So there are two things going here. One of them is determining whether it's a function, because you can have render props or function as children. In this case, your children will be a function. Otherwise, it's gonna be an array. And what happens is just basically from row children is the arguments after the config, which will be basically the props, and you just make sure that it's not null, and then you check that if it's an object, then return it, or otherwise create a text element. And this is text element is also part of the Babel transpilation, and it knows how to create and how to make the text element and attach it as a children. So that's, we're not gonna touch it, it's just gonna be imported wherever we use JSX, because otherwise Babel will have no idea how to compile JSX to React function calls. Alright, so that's for this video, and next time we can actually start writing some document create element stuff. Alright guys, see you then, and have a lovely day.